Today I will be solving ATP paper 4-1 of O level from May-June 2022. Let's start. Question number 1. A student transferred 4 cm³ of aqueous potassium manganate from the burette into apparatus A. This is the burette and this is apparatus A. Name the apparatus A. Apparatus A is, you are very well aware of this apparatus. This is conical flask, and student adds 25 cm³ of dilute sulfuric acid to apparatus A. Name a suitable piece of apparatus to measure the 25 cm³ of acid, that is measuring cylinder. The student heats the mixture in apparatus A until it reaches 60 degrees centigrade. Name a suitable piece of apparatus to measure the temperature, that is thermometer. The student places apparatus A containing the hot mixture on a white tile. Add 10 cm³ of aqueous glucose to apparatus A. 10 cm of glucose to apparatus A. Starts a stopwatch, stirs the content of apparatus A and record the temperature. Stops the stopwatch when the color changes. Record the time taken. The student does this experiment at 5 different temperatures. The results are shown in the table. So this is the graph I have drawn earlier for you to save the time. Labeled X's on the grid include appropriate units. Units are very important, mentioned along with the physical quantities, temperature measured in degree centigrade and time in second. So this is the first line 55 at 5 second, and this is the second reading 40 at 25, 40 at 25 and 40 at 32. This is 48 at 32. This is at 32, 48, and again next reading is 90 at 23. This is the 90 and 3, and draws this curve. Time, look at the time at 25 cm³. Time measured at, label the x-axis, plot the graph 1 mark, plot the result on the grid, draw a curve of best fit, use the graph to determine the time taken at 25 degrees centigrade. So at 25 degrees centigrade, look at here, this is at 25 degrees centigrade, and this is 64, 68 and 72. This is nearly about 72 or 73. This is 72 or 73, you can write down 73. Second, temperature at extend your curve of best fit to determine the temperature at which the reaction takes 180 seconds. Suggest why an experiment at 70 degrees centigrade is not done. Time is too short to not done at 70 degrees centigrade. 70 degrees centigrade, till 70 degrees centigrade time is very short to carry on this apparatus. 70 degrees centigrade. So now 180 second, this is 180 second. So this is at 180 second. So time is nearly about 20. So this is exact 20. So time taken is 20 degrees centigrade. Temperature at 182nd it is 20 degrees centigrade. So suggest why an experiment at 70 time is too short to carry on this apparatus till 70 degrees centigrade. Now next question is, a student has a mixture of solid ionic compounds. The student adds the mixture to the beaker with water. A student has a mixture of solid ionic compounds. The student adds the mixture to a beaker with water and stirs the contents of the beaker. The beaker contains a colorless solution and an insoluble black solid. Draw a diagram to show how the student separates the colorless solution from the black solid. Label the apparatus, the black solid and the colorless solution in your diagram. So filtration is used to filter this solution mixture. So this is beaker and this is funnel. And this is filter paper. This is filter, 3 folds of filter paper, and over the filter paper here is the black solid. This is black solid. This is filter funnel. And this is filter paper. And process is known as filtration. So carrying 3 marks, you must draw the label diagram. Okay. The student tests the colorless solution as this is the colorless solution. This is colorless solution. And this is mixture of student beaker with water stirs the content of the solid ionic compound. Beaker contains the colorless solution and insoluble black solid. Okay. The student tests the colorless solution as shown in the table. Complete the table. Add dilute hydrochloric acid followed by aqueous barium chloride, followed by aqueous barium chloride. So this is the solution of barium chloride. This is the test for sulfate ion. The mixture contains sulfate ions and carbonate ions. So the observations are effervescence of gas, which turns lime water milky. And for sulfate ions, barium with addition of barium chloride, white precipitate of barium sulfate. Conclusion are solution contains carbonate ions, mixture contains sulfate ions and carbonate ions. So conclusion is carbon dioxide gas shows carbonate ion and barium chloride, with addition of barium chloride, conform sulfate ions, white precipitate of sulfate ions. Aqueous sodium hydroxide and warm the mixture. Warm the mixture. This is the test of ammonium ion and effervescence of gas. Turns damp red litmus paper blue. It means it contains ammonia gas. Add dilute nitric acid followed by silver nitrate. A pale yellow precipitate is formed. Aqueous silver nitrate. If the observation is pale yellow precipitates, it means effervescence, bubbling and fizzing. So this is add dilute nitric acid followed by aqueous silver nitrate. This is test of iodide or chloride or bromide. If a pale yellow precipitate is formed, it means iodide ions. Iodide ions are present. Use the conclusion from test 2 and test 3. This is test 2, this is ammonium ion, and test 3 only to name an ionic compound in the mixture. So test 3 confirm the iodide ions and test 2 confirm the ammonia gas if effervescence of gas can be seen, and it turns damp red litmus paper blue. So the formula is, name of an ionic compound is ammonium iodide. The student tests the insoluble black solid as shown in the table. Complete the table, put the black solid into dilute sulfuric acid. Black solid is copper 2 oxide, and if it reacts with dilute sulfuric acid and warm the mixture, the black solid dissolves in blue solution is formed. It means solution contain black solid contain copper 2 ions. To sum up the blue solution from test 1, add sodium hydroxide drop by drop until it is in excess. A light blue precipitate is formed which is insoluble in excess. It means copper 2 ions are conformed. Light blue precipitation which is insoluble in excess dissolves in excess. So copper 2 ions are conformed. to sum of the blue solution from test 1 aqueous ammonia drop until it is in excess. Light blue, precipitates with few drops of ammonia which dissolves to form dark blue solution in excess. A solution has question number 3. A solution has 3 colorless organic liquids W, X and Y. One is an alkene, one is alcohol and one is carboxylic acid, but the student does not know which liquid is which. Describe a series of tests to determine which liquid WXYZ is alkyne, which is alcohol and which is carboxylic acid. Each liquid must be identified by a positive test: alcohol, alkene and carboxylic acid. You are provided with separate samples of liquid W, X and Y. Acidified aqueous potassium manganate, aqueous bromine, solid calcium carbonate, the apparatus namely found in the school laboratory. Description of test, the appearance apparatus needed for the test, how the results of the test are used to identify W, X, Y and Z. Okay, W, X, Y, Z. And W, X and Y in separate test tubes and add aqueous bromine in all test tubes. The test tube the sample which turns aqueous bromine from brown to colorless identifies the alkene. Now add aqueous potassium manganate in rest of 2 samples if the solution turns acidified KMnO4 from purple to colorless, from purple to colorless, identified the alcohol. And left behind sample causes effervescence when sodium carbonate is added in the test tube. Added in the identifies carboxylic acid. All are organic, all samples, all X, W and Y are organic liquid so near the flame, because all are flammable substances. Acid is corrosive or, wear goggles. Question number 4. A student determines the concentration of aqueous sodium hydroxide by titration with aqueous citric acid. Record the mass of an empty beaker, then add citric acid. Record the mass of the beaker and the citric acid. Add distilled water to the beaker and stir the mixture until all the citric acid dissolves. Transfer all of the citric acid from the beaker into 250 volumetric flask. Fill the volumetric flask up to the mark with distilled water and shakes the flask to make solution P. uses a measuring cylinder to add 25 centimeter cube of P into a conical flask, adds a few drops of indicator to the flask, fills the burette with aqueous sodium hydroxide. So acid is in conical flask and fills the burette with aqueous sodium hydroxide and record the initial volume in the burette. Adds sodium hydroxide aqueous to the flask until the indicator changes color and records the final volume into the burette. The student repeats step 6 and to 9 3 times. The student uses an incorrect piece of apparatus to measure a volume. Identify the incorrect piece of apparatus and suggest a more accurate piece of apparatus. Incorrect piece of apparatus is measuring cylinder. 25 centimeter measuring cylinder. So instead of measuring cylinder, we use pipette. Incorrect measuring cylinder and correct piece of apparatus is pipette. Explain why the content of the volumetric flask are shaken in step 5. Make sure to equalize the concentration. In step 5, fill the volumetric flask up to the mask. Mark with a distilled water and shakes to the flask to make solution P. Equalize the concentration in the concentration of acid. Explain why the indicator is needed in step 9. To identify the reaction, to identify the end point or neutralization point, or you can write down that reaction is over or complete. The diagram shows the masses on an electronic balance. Calculate the mass of citric acid added to the beaker. This is citric acid 50.32 and this is the beaker. This is the whole container now 50.32 minus 45.36. It is 4.96 gram. Calculate the number of moles of citric acid added to the beaker. Gives your answer to 3 significant figures. So mole is equal to mass over mR. Mass is 4.96 divided by mR of citric acid is 192. The answer is 0.03 significant, 0.0258. Calculate the concentration in mole per dm cube of citric acid in the volumetric flask. So calculate the concentration in mole per dm cube of citric acid in the volumetric flask. Concentration is equal to mole over volume into 1000. mole is 0.0258. In volumetric flask, 250 centimeter cube is volume into 1000. Because concentration is in mole per dm cube, the answer is 0.103. The diagram shows parts of the burette with the liquid levels at the beginning and at the end of the titration 1. Final burette reading. It is 35.1234567. Final is 35.7 and initial is 4.2, and the volume of sodium hydroxide added is 31.5. So these are the four titration readings. The best titrations are 30.9, 30.7, 30.8. So these are the best results. The table also shows the results of 3 other titrations. Complete the table by ticking the best titration results. Explain why you have ticked these values. As all values are within 0.2, so use the best titration results to calculate the average volume of sodium hydroxide used. Use the best titration results to calculate the average volume of sodium hydroxide used. 30.9 plus 30.7 plus 30.8 divided by 3. So the average volume is 30.8. Use your answer to F to calculate the number of moles of citric acid in 25 centimeter cube of solution P. 25 centimeter cube of solution P. Use your answer to F. F is the 0.103. Number of moles of citric acid in 25 centimeter cube of the solution P. Mole is equal to 0. This is 103. Concentration 0.103 into 25 divided by 1000. 25 divided by 1000 is equal to into 0.103. This is equal to 0.002575 or 0.00258. The equation for the reaction between citric acid and sodium hydroxide is shown. Calculate the number of moles of sodium hydroxide that react with the citric acid in 25 centimeter cube of solution P. So by using mole ratio 1:3, the moles of citric acid is 0.00258 ratio X. So doing cross multiply, it is equal to 0.00775. Calculate the concentration in mole per dm cube of sodium hydroxide. Concentration of sodium hydroxide is equal to mole over volume 2000. Mole is equal to 0.00775 divided by 30.8 into 1000. It is equal to 0.252. 25 centimeter cube of sodium hydroxide is added to in excess of iron 2 sulfate. The equation for the reaction is shown. A precipitate is formed. Use the equation and your answer from L. Calculate the number of moles of iron 2 hydroxide that is made. If you do not have a value for the concentration of sodium hydroxide, assume it is 0.255 mole per dm cube. This is not the correct value. So moles sodium hydroxide is equal to 0.252 into 25 divided by 1000 is equal to 0.0063. And now by using mole ratio 2:1, iron 2 hydroxide is 1 mole and sodium hydroxide 2 mole. 0.0063 into X. 0.00, it is equal to 0.00315. State the color of the precipitate: green. Question number 5. Measures 25 centimeter cube of hydrochloric acid in a glass beaker. Measuring the temperature of the hydrochloric acid, adds 30 centimeter cube in excess of aqueous potassium hydroxide. Records the maximum temperature the mixture reaches. Initial temperature is 19. Final temperature is 28. The temperature change is 9 degree. Use the information in the table in A to suggest what type of reaction is taking place. It is exothermic, as temperature is going to rise in the thermometer. The student repeats the experiment using 2 mole per dm cube instead of 1 mole per dm cube of hydrochloric acid. Volumes are kept constant. The aqueous potassium hydroxide is still in excess. Predict the temperature change in this new experiment. Explain your answer. It is 18 degrees centigrade. So the concentration of HCl is doubled. So temperature change is doubled. The temperature change measured is lower than expected. Suggest a reason for the temperature change being lower than expected. As heat loss, due to heat loss. Suggest an improvement to the experiment which will make the measured temperature closer to the expected value. Use a polystyrene cup. Or you can use plastic, or instead of polystyrene, insulate the beaker. So this is all about the paper. So hopefully you would understand this paper, and if there is any query, please feel free to ask the questions in comment box. Subscribe this, please subscribe my channel and like the video.